Good morning, upper bound students. In today's lecture, we're going to be covering solving quadratic equations using the zero product rule. Solving quadratic equations is a very important skill to be able to develop. And typically this gets used in a lot of other classes that you would see that comes after this. So things like college algebra, even within trigonometry classes, and especially in calculus, a lot of situations come up that require us to solve a quadratic equation. The first thing we want to discuss before jumping to quadratic equations is let's review what we meant by a linear equation in one variable. A linear equation in one variable is simply an equation where you have one variable, oftentimes it's going to be x, and the understood exponent is going to be to the first power. So if you have a variable to the first power along with some additional coefficients, so that a, b, and c would be real numbers, and we require that a is not equal to 0, otherwise this whole term would be 0 and the variable wouldn't show up in the first place. So we always want, in any polynomial equation, we always require that the leading coefficient be non-zero. Okay. So that's what we meant by a first degree polynomial. It's just a linear equation. The highest power of the variable you have is to the first. Now let's take a look at a quadratic equation, which is a second degree polynomial equation. The difference this time is now our highest power of x is going to be x to the second power. So we can have an x to the second power term. We can also contain a linear term, which would be the bx plus c part of it, and this whole thing is going to be set equal to 0. So this is what we would refer to as a quadratic equation in standard form. One of the habits we want to get into whenever you're trying to solve a quadratic is always begin, if it's not already done so, always begin by putting it into this format. What that means is you want one side to be equal to 0, and then after that we want to make sure that we have all of our x terms and our number terms on the other side of the equation, and we want to write them in terms of decreasing powers of x. So the highest power of x should come first, then the next smallest power, all the way until you get down to maybe a term that doesn't have an x with it. That would be like your constant term. Okay. For example, if I had the equation 2x squared minus 3x plus 7 equals to 0, this is an example of a quadratic equation in standard form. First thing we would kind of notice is that, okay, it's of degree 2, that's our x squared term, and it is in standard form because the powers are decreasing. The x squared term comes first, then the x to the first power term comes second, and then lastly we save the constant term. Another example of a quadratic equation would be something like this. Negative 5x minus 6x squared equals to 8. When I look at this, it's not in standard form, first of all, because we don't have 0 on one side. But second of all, I would know right from the beginning that it's a quadratic equation because the highest power of x is going to be that x to the second power. So first thing we want to do is we want to put this thing in standard form, and to do so we want one side to be equal to 0. So let me go ahead, I'm going to begin by subtracting 8 from both sides. That'll set the right hand side equal to 0, and now we get negative 5x minus 6x squared minus 8 equals to 0. That's a little bit better, but it's not quite in standard form yet because we don't have the terms listed in decreasing power of x. When we write our quadratic, we want the x squared term to come first, then the x term, and then the constant term, and then that whole thing should be equal to 0. So now this is our quadratic equation written in standard form. In the first couple exercises, you'll have to do 2 in the quiz. Let's do 1 and 3 together. We are asked to identify each equation as linear, quadratic, or neither. In order to answer this question, we want to look to see what is the highest power of x. If we look at example number 1, we see that the highest power of x is x to the second. So that means that this is going to be a quadratic equation. Notice that it's already in standard form because we have the highest power of x first, so the x squared term comes out in front. We then have the x term, which is negative 16x. Notice that there isn't any number added or subtracted here, so essentially what that's telling us is that the constant term is equal to 0. If we take a look at question number 3, we see that the highest power of x is x to the 4th. So that's a higher degree polynomial. That's not linear or quadratic. This would fall into the neither category. Okay. So we would refer to the type of problem in question 3. It would just be a higher order polynomial. It's a polynomial of degree 4. It's not linear, nor is it quadratic. One of the things that's going to allow us to solve these quadratic equations is something called the zero product rule. And this is something that maybe you haven't necessarily thought about in a while, but it's something that intuitively we all kind of know when working with the real numbers. And that's that if you take two numbers and multiply them together, so let's suppose I take a times b, and let's suppose that that multiplication results in getting a zero value. The only way that can happen is if one of the original two numbers themselves were 0. So if a times b equals to 0, then either the first number had to be equal to 0, so either a equals to 0 or b equals to 0. So the zero product property, when we start to kind of get into the solutions by factoring, all of it really relies on this property of the real numbers. Let's see what this is going to look like. Let's take a look at example 5. We are asked to solve these quadratic equations using the zero product rule. In question 5, we have 2x minus 1 times, remember that's an implied multiplication here, times 4x plus 5 equals to 0. This expression, if we kind of look at it, it's in the form something times something equals to 0. So this factor times this factor equals to 0. According to the zero product property, the only way that can happen is if one of these two factors is equal to 0. So this means that either 2x minus 1 is equal to 0, or that 4x plus 5 is equal to 0. Okay, and that's a direct consequence of the zero product property. What's nice is if we look at this line right here, individually each one of those equations is a simple linear equation. And those are things that we know how to solve. For example, to solve the first one, we want to get x by itself. You would simply add 1 to both sides. That would give us 2x equals to 1. And then lastly, to get the x by itself, we would divide both sides by 2. Divide by 2, divide by 2. We would get x equals 1/2. That's one solution. Over here, to solve for x, we would first go ahead and subtract 5 from both sides. So minus 5 minus 5. We get 4x equals to negative 5. And then the very next step, to get the x by itself, we would divide by 4. And this would give us x equals negative 5/4. So as it turns out, this equation has two solutions. Those two solutions are x equals to 1/2 and x equals to negative 5/4. One of the things that we know from equations in general is that if you're unsure of your answer, you can always go ahead and plug it back into the original and see if it gives us a true statement. So let's check what happens if x equals to 1/2. Will that be a real solution to this equation? Well, everywhere we see an x, let's replace it with a 1/2. So I'm plugging it back into the original expression, and we want to know, the question is, does that truly equal to 0? Let's do a little bit of math here. 2 times 1/2 is 1, and then 1 minus 1 would be 0. So the first factor is going to be 0. 4 times 1/2 is 2. 2 plus 5 is 7. And sure enough, 0 times 7 is 0. So we checked x equals to 1/2, we plugged it back in. We got 0 equals to 0, which is a true statement, and that verifies that x equals to 1/2 is a solution. Okay. Quadratic equations in general aren't a type of equation where you necessarily always have to check your answer, but when you're first learning, it's not a bad idea, especially if you work out a question and you feel a little bit uneasy or if you're unsure of yourself. You can always plug these back in to see if they actually do work and are solutions. I'm going to skip that part, but if you wanted to, I'll leave it up to y'all, but you can check x equals to negative 5/4 on your own and show that that one too would be a solution. Okay. Another comment that I want to make, and we're going to focus on this in a little bit, even though 5 isn't in the form of a quadratic equation in standard form, if you were to multiply and distribute everything out, it would end up being a quadratic equation, a polynomial of degree 2. One of the things that's interesting with these polynomials of degree 2, and it's very common, is because it's an equation of degree 2, we actually ended up in this case getting two solutions. X equals to 1/2, x equals to negative 5/4. On this week's quiz, when you go to put in your answer, the way that we're going to answer them, you'll put x equals, because that's the variable, you'll just put your two answers separated by commas. Okay? And we want those two answers to be in increasing order. So of the two solutions, negative 5/4 was the smallest. So I'll put x equals negative 5/4, comma, and then 1 divided by 2. This is how you'll enter it into your D2L quiz. Now this brings us to solving equations by factoring. In order to solve a quadratic equation by factoring, the first step we want to do is write it in standard form. Again, standard form means we want one side to be equal to 0, and then on the other side we want all of our terms to be listed in terms of decreasing powers of x. So we want the x squared term first, then the x to the first power term, and then the constant term. Once we have it in standard form, the goal then, and this is why we've been focusing so much on this chapter, is to then factor the expression on the left-hand side. So when we factor it, we're hoping to write it like something times something will be equal to 0, and then we can apply the zero product property to solve it from there. So again, solving equations by factoring, there's 3 steps. First step, put it in standard form, one side to 0, decreasing order. Step 2, we're then going to factor that left-hand side completely, and then once that left-hand side is factored completely, then we're going to use the zero product rule, which will allow us to set each of the factors equal to 0 individually. Let's take a look at number 7 together. In question 7, we're asked to solve the equation b squared plus 3b minus 40 equals to 0. We know that this one is a quadratic equation because it's the highest power is to the second power, and it's already in standard form. We have one side to be 0, and it's written in terms of decreasing powers of b. So the next thing we want to do is we want to go ahead now, this is going to be this next step, we want to factor that left-hand side. This is a trinomial. Furthermore, it's one of the easier ones where the leading coefficient is 1, so we know it's going to be a b and a b. We then need to check the sign. If the last term is negative, we automatically know that we're going to have one positive and one negative. And now let's consider the factors of negative 40. The factors of negative 40 would be negative 1 and 40, negative 2 and 20, negative 4 and 10, negative 5 and 8, and then these would kind of get reversed. So we can stop there. You could also have the negative sign on the other factor. So let's see what we have here. So again, the end goal here is we want two numbers that multiply to give negative 40. Those two numbers have to come from this list, but in addition, we need them to add to give a positive 3. And if you look at the combination that's going to work, it's going to be the negative 5 times 8. Negative 5 times 8 obviously gives us negative 40, but in addition, negative 5 plus 8 equals positive 3. So when we go to fill in our parentheses, the 5 is the one that has to be behind the negative sign, and the 8 is the one that has to be behind the plus sign. Again, factoring is one of those things you can check. If you don't feel confident or if you're unsure, you can go ahead and distribute. Some people would say FOIL, and just to check that this would indeed result in getting b squared plus 3b minus 40 equals 0, which it will. So that part is now done. We have it completely factored. And now what we're going to do, if we look at it, we have something times something equals to 0. According to the zero product rule of real numbers, either the first factor, that is b plus 8, has to be equal to 0, or b minus 5 has to be equal to 0. We can now solve each one of these individually. For the first equation, to get the b by itself, we're going to subtract 8 from both sides. So one solution is b equals to negative 8. And then for the second one, we can add 5 to both sides. So plus 5, we get b equals to positive 5. Again, when you go to key this into D2L in the quiz, your answer would go in the blank as b equals the smaller value, comma, the bigger value. So two roots here, b equals to negative 8, b equals to positive 5. Let's take a look at number 9. Here we're asked to solve 4r squared minus 17r equals to 15. When we look at this, again, it's going to be a quadratic equation because of that second power term for r. That's the highest power, so that makes it a quadratic. Be a little bit careful, though, because when we're starting off with example number 9, this is not in standard form. And the reason why it's not in standard form is we don't have one side equal to 0. So the very first thing we want to do to get the ball rolling here is let's subtract 15 from both sides so that we can get the right-hand side to be 0. This will give us 4r squared minus 17r minus 15, which is just a constant. And then on the right-hand side, 15 minus 15, that is equal to 0. So we now have the right-hand side equal to 0. Now we want to go ahead and solve this thing. Okay. This is a trinomial, so we want to factor it. This is a trinomial whose leading term is not equal to 1. So these are the ones that are typically a little bit more involved. So in order to factor this, let's go ahead and use the AC method. Some people can use the guess and check, which we talked about last week, but I'm going to solve this one with, factor this one, I should say, with the AC method. So let me remind you how the AC method works. So we have 4r squared minus 17r minus 15. I'm just kind of taking it out of context. Right now we're just trying to factor this. In a quadratic, why the AC method gets its name is from the coefficients of the leading term and the constant coefficient. So that's the A and the C when this thing would be in standard form. That means for us that A, that's going to be the coefficient of the r squared. So that's a coefficient of 4. So A equals to 4. And then C is the constant coefficient. That constant coefficient is negative 15. So C equals negative 15. What we do with the AC method to factor is we multiply A and C together. So we do A times C. 4 times negative 15, that is equal to negative 60. And then what we do is we are now going to proceed to write out all of the factors of negative 60. For example, I can do negative 1 times 60, that would work. 2 can go in 30 times. 3 can go in 20 times. 4 can go in 15. 5 can go in 12 times. 6 can go in 10 times. 7 can't divide. 8 can't divide. 9 cannot divide. And then we're back to 10, which will just relist these in opposite order. We also have a separate list where instead of having the negative on the first factor, you could essentially put the negative on the second factor. right? I mean, after all, yes, it's true, for instance, that negative 2 times 30, positive 30 gives us negative 60, but so too is it that positive 2 times a negative 30 would give us negative 60. The next thing we're looking for now is so these are obviously the factors that multiply to give negative 60. We now want to find the pair that would add to give us the middle coefficient, which is negative 17. So we're going to look through this list. We need to find a pair that adds to give negative 17. And the answer is it's going to be this pair right here. Right? Not only does 3 times negative 20 give us negative 60, but if we add it up, a 3 plus a negative 20 would give us negative 17. So those are the factors we're going to use. From here, what we do is we're now going to split apart the middle term. So I leave the first term alone, I leave the last term alone, but now here's what we're going to do. Instead of calling it a negative 17r, I'm going to call it a positive 3r and a negative 20r. So we've split it apart. Notice nothing's really changed. We still have the 4r squared. That's still there. The negative 15 is still there. And what we're doing is we're just kind of splitting up this middle term into a positive 3r and a negative 20r. Notice if we recombine these, the positive 3r and the negative 20r would return us to the negative 17r. However, the benefit of splitting it up, according to this choice, what that now gives us, if we count them out, is 1, 2, 3, 4 terms. And if you go back, one of the first methods of factoring we learned when we have 4 terms is factor by grouping. So that's how we finish the AC method. We're going to group the first 2 terms together, our 4r squared plus 3r, plus, now we have a negative 20r being grouped with a negative 15. To do the factor by grouping method, we now pull the GCF out of each parenthesis. The first grouping has a common factor of r. When we factor that out, we're left with 4r plus 3. The GCF here between these 2 terms would be 5, but in addition, because the first term is negative, we always want to factor out that negative GCF. So we can factor a negative 5 out of the second parenthesis. That's going to give us a 4r plus 3. And if we look at what's left, we have technically 2 terms now, and both of those terms have a factor of 4r plus 3. That makes the quantity 4r plus 3 a common factor, so we can pull it out. When you remove it from the first term, we're left with r. When we factor it out and remove it from the second term, we're left with a minus 5. Okay. So there you have it. 4r squared minus 17r minus 15. To factor this, it factors as 4r plus 3 times r minus 5, and that's using the AC method. Again, for those of you that are very well versed and have done a lot of factoring, you very well might be able to do this with the trial and error method. I find that students that tend to struggle with factoring ones like this get discouraged because they feel like it's just trying to throw something at a wall and just kind of like going through possibilities to see what sticks. Whereas if you use the AC method, it makes it a very systematic approach. It says if you do step 1, step 2, at the end of the day, you will always get the correct factorization without any need for guesswork if you use this procedure. Okay, so that was just one step. That was just getting this thing factored. We now have it factored. So where we we're here, we have 4r squared minus 17r minus 15 equals to 0. So again, step 1, put it in standard form. Step 2, we now need to factor the left-hand side. We did that. We got 4r plus 3 times r minus 5 equals to 0. And now the next step is we're going to set each factor equal to 0 individually. So we have something times something equal to 0. According to the zero product property, either the first term or the second term has to be equal to 0. To solve the first factor, we would begin by subtracting 3 from both sides. We get 4r equals to negative 3. And then we can divide both sides by 4. So one solution is going to be r equals negative 3/4. For the second one, we can add 5 to both sides, and we get the solution r equals to 5. So for this quadratic equation, we have two solutions again. They are r equals to negative 3/4 and r equals to positive 5. Let's take a look at the next one, number 11. In problem number 11, we have 0 equals 3t squared minus 18t minus 48. This is a quadratic equation, again, because the highest power of the variable t, is the second power. So it is a quadratic. It's also already in standard form for us. We just happen to have the 0 on the left-hand side this time, which is okay. And when we look at the right-hand side, it is in terms of decreasing powers of t. So we're now ready to go ahead and try to factor the right-hand side. Notice that in trying to factor the right-hand side, there's a GCF this time. So don't ever forget about the GCF. It was the first method of factoring we learned at the very beginning of the section, but it's the one thing you should always look for whenever you start any kind of factoring process. Here, if we look at all of these terms, they all have a common factor of 3. So let's begin by factoring the 3 out. If we factor a 3 out of the right-hand side, that's going to give us a t squared minus 6t minus 16. Notice that that's going to save us a ton of work. If you don't notice this, then essentially what you're going to be left with is trying to factor a trinomial where the leading coefficient is not equal to 1. Once we factor that 3 out, we get t squared minus 6t minus 16, which is going to be much, much easier to handle. Because it's a leading trinomial whose leading coefficient is 1, we know it's going to start with a 1t and a t. Anytime the last term is negative, we know our factors have to be 1 plus and 1 minus. And now we need the factors of negative 16. Those would be negative 1 and 16, negative 2 and 8, negative 4 and positive 4, or you could reverse the symbols. So let's put the negative on the other factor. Notice these two end up being the same. One's positive 4, one's negative 4. But we need the combination that multiplied to negative 16 and would also add to give negative 6. That combination, if we look for it, should be right here. It's going to be a positive 2 and a negative 8. 2 plus negative 8 would give us negative 6. So when we go to our factorization, notice the 2 is going to have to be behind the positive sign because it's positive, and the 8 is going to have to go behind the negative. So it's going to be t plus 2, t minus 8. Everything is now factored completely. So what we're going to now do is set each factor equal to 0. Notice we actually have 3 things here. Some people would actually divide the entire equation by 3 to start instead of factoring it out. But if we set each piece equal to 0, the first part, 3 equals to 0, that's a contradiction, so there's no solution from this part, right? There's no variable with the 3, so it's not going to be equal to 0. So you can ignore the constant when you're solving these. You don't have to set the constant equal to 0 because you're not going to get any solutions from that part. We will get some solutions where either this factor or this factor equals to 0. To solve t plus 2 equals to 0, we're going to subtract 2 from both sides, and we would get t equals to negative 2. Here we would add 8 to both sides, add 8, add 8. That's going to produce t equals to positive 8. So again, we get 2 solutions right now. They are t equals to negative 2 and t equals to positive 8. The next one we're going to look at together is number 13. And on the surface, this one might look to be a little bit different than the other ones that we've seen. When we look at question 13, it's 2x cubed minus 5x equals to 3x squared. This is not a quadratic equation. And the reason why it's not a quadratic equation, this would fall into our neither category, is because the highest power of x is of degree 3, because of the x cubed term. Nonetheless, as it turns out, if we want to work with even higher degree polynomial equations, let's say something like an x to the third power equation, or like an x to the fourth or the fifth, they all have the same first step. And that same first step is putting it in standard form, which would mean get one side to be 0, and then we're going to write the other side in decreasing powers of x. So let's do that and let's see what happens here. We want to get one side to be 0, so I'm going to subtract 3x squared from both sides. On the right hand side, 3x squared minus 3x squared, that cancels, so that gives us 0. On the left hand side, we're going to have three terms. We're going to have an x cubed term, an x squared term, and then an x to the first power term. Notice that they're not like terms, so we can't combine them, but we can write them in standard form. The highest power goes first, so I write the x cubed term first, then I write my x squared term next, and then lastly we'll write the linear term, which is the negative 5x term. So we now have our third degree polynomial equation is set equal to 0, and one of the things that's going to help us a lot is, again, think about the GCF here. If we look at those three terms, the goal is to factor the left-hand side. And because all of them have a common factor of x, we can pull the x out. If we factor an x out of that left-hand side, that's going to leave us now with a 2x squared minus 3x minus 5 equals to 0. So the x is now factored out, and then we have this 2x squared minus 3x minus 5. This piece would be a quadratic expression, so we should be able to go ahead and factor it. So remember, whenever you're factoring, the goal is to always factor it completely. So let's kind of go off to the side. I'm going to use the AC method again on this one. So let me do that on a separate piece of work. So right now we're trying to factor that quadratic part of our question. We want to factor 2x squared minus 3x minus 5 equals to 0. Okay, we're going to use the AC method because it's a trinomial whose leading coefficient is not equal to 1. The value of A is 2. The value of C is negative 5. So we form the AC number. We do A times C. 2 times negative 5 is going to give us negative 10. So the AC value is negative 10. We now write out all of the different factors of negative 10. They are negative 1 and positive 10, negative 2 and positive 5, and then this order would flip. We can also put the signs on the other factor. So 1 with negative 10 or 2 with negative 5. We now need to choose the combination that will add to give us the middle coefficient. The combination that multiplies to give negative 10 but adds to give negative 3 should be this combination right here, a positive 2 and a negative 5. 2 plus negative 5 will give us the negative 3 that we want. Okay, so now that we know that, the way the AC method works is we use those two numbers to split apart the middle term. Instead of calling it a negative 3x term, we're going to use these two numbers to break it apart. So I can call it a positive 2x term and a negative 5x term. Again, it hasn't changed the value of the expression, it's only given us more terms to work with. The 2x squared is still there, the negative 5 is still there, And we're taking the negative 3x and we're breaking it apart into a positive 2x term and a negative 5x, where those two numbers are the ones that we found over here that worked. Again, positive 2x plus negative 5x would give us back the negative 3x we started with, but by breaking it apart, we now have 1, 2, 3, 4 different terms. And because we have 4 different terms, we can do a factor by grouping. I'm going to group the first two terms together, 2x squared plus 2x, plus I'm going to group the last two terms together, negative 5x minus 5, and these are going to be equal to 0. With our grouping, we now pull the GCF out of each grouping. From the first grouping, we can factor out a 2x because that's the GCF. That'll leave us with an x plus 1. Out of the second grouping, the GCF is 5, but because the first term is also negative, I'm going to factor out a negative 5. When we do that, that gives us an x plus 1. And now we have two terms, and both of them share a common factor of the quantity x plus 1. So we can go ahead and factor out the x plus 1. When I factor out the x plus 1 from the first term, we would be left with a 2x. When we factor it out from the second term, we would be left with a minus 5. I'm not setting it quite equal to 0 yet. We'll do that in a minute. But we've now just factored the expression that we wanted. 2x squared minus 3x minus 5. The way that it factors is it factors as x plus 1 times 2x minus 5. So we can come back here. So we had one side to 0 first. We had our 2x cubed minus 3x squared minus 5x equal to 0. We noticed that we had a GCF of x, which we could factor out. That left us with a 2x squared minus 3x minus 5 equals to 0. From there, we were able to factor this trinomial. We said that it factors as x plus 1 times 2x minus 5 equals to 0. And now we're going to apply the zero product rule, so the zero product property. We have something times something equals to 0. The only way that can happen is if one of these three factors equals to 0. So we set the x equal to 0. That's the first factor. We set the x plus 1 equal to 0. And we also set the 2x minus 5 equal to 0. This one is already solved for us. It's just x equals to 0 is one solution. For the middle one, we'd have to subtract 1 from both sides. We would get the solution x equals to negative 1. And for the last part, we would need to add 5 first. That would give us 2x equals to 5. And then we would divide both sides by 2. And we would get x equals to 5 halves. If you're kind of following along, it makes kind of nice sense that if we go back, remember, this wasn't a quadratic. This was actually what we would call a cubic equation. It's a polynomial of degree 3. And not coincidentally, notice that we actually got 3 solutions. They were 0, negative 1, and 5 halves. So if you're kind of seeing a pattern, you might actually notice that there is one. I'm not going to get into it in this video, but if you're curious, if you want to investigate that pattern more, look up the fundamental theorem of algebra. Theorem of algebra. When you go to put this answer into D2L, again, we want it in terms of increasing powers of our roots. So the first one, the smallest one, was x equals to negative 1, then comma, the next one would be 0, and then comma 5 halves, which would just go in as 5 divided by 2. So when you go to put your answers in the D2L quiz, that's what it should go in like. We have one more to do. Let's take a look at question 15. It's 3s cubed plus s squared minus 12s minus 4 equals to 0. This one is yet again another example of one that's not a quadratic equation. And the reason why it's not a quadratic equation is because the highest power of the variable s is of degree 3. So this would be what we would sometimes call a cubic equation. To solve any polynomial equation, whether it's a quadratic or higher, we would first want to put it in standard form. That part's already done for us. We do have one side to be 0, and if we look at the expression on the left-hand side, it is in standard form. It is listed in terms of decreasing powers of s. We have s to the third, then s to the second, then s to the first, and then our constant term. So that part is already done. The next step would be to try to factor this left-hand side. Unlike the last one, there is no GCF of all of these terms, so we can't do a GCF. But if we look at how many terms we have, again, we're in a situation where we have 1, 2, 3, 4 different terms. And we know that whenever we have 4 terms, we should always try to do a factor by grouping. So let's group the first 2 together. And let's group the last 2 terms together. Out of the first expression, the GCF would be s squared, so we can factor s squared out of the first grouping. That'll leave us with a 3s plus 1. Out of the second grouping, the GCF is 4, but we're also going to factor out a negative, so factor out negative 4. That will also leave us with a 3s plus 1 equals to 0. And now that we have it broken out like this, we have 2 terms, both of which have a common factor of 3s plus 1. So we're going to factor out the quantity 3s plus 1. When we do that, when we factor it out of the first term, we're left with a s squared. When we factor it out of the second term, we're left with a negative 4. So this factors as 3s plus 1 times s squared minus 4. We're not quite done yet because this expression will factor more. So we always want to factor completely when we can. Hopefully we all recognize this from last week's material, but this is a difference of squares. The way that the difference of squares factors is it's going to be s and s. You always have 1 plus and 1 minus sign. And then the number we would square to get 4 would be 2. So s squared minus 4, that's a difference of squares. It factors as s plus 2 times s minus 2. Everything is now factored completely. We have that left-hand product equals to 0. According to the zero product property, the only way that can happen is if each one of these factors individually could be equal to 0. So we have 3s plus 1 equals to 0, or s plus 2 equals to 0, or s minus 2 equals to 0. For the first factor, we can subtract 1 from both sides. We get 3s equals to negative 1. Divide by 3, divide by 3, s equals to negative 1/3 is one solution. For the middle one, we would subtract 2, and that would give us the solution s equals to 2. And then lastly, for this one, we would add 2, and we would get s equals to positive 2. And very quickly, I see I'm going to drop the sign here. 0 minus 2 on that previous one, by the way, everybody was minus 2. And then this one will give us the s equals plus 2. So interestingly enough, we had a polynomial of degree 3. You still get one side equal to 0. You still write the other side in decreasing power of the variable. We then try to, whatever methods we have, factor that left-hand side, which we did. We then go ahead and, according to the zero product property, we set each factor equal to 0 individually. That will tend to lend itself to a bunch of simple linear equations. We solve them like we know how to all the way back from the beginning, and we get 3 solutions on this one. S equals to negative 1/3, S equals to negative 2, and S equals to positive 2. I hope that helps. If you have any questions on this week's material, again, please email me or set up an appointment where we can go over some more of these together.